Hello guys, in this session we speak about statistics in Python, starting with descriptive statistics, finding mean, maximum, and so on, then central tendency, mean and median, variability, such as variance and standard deviation, summary correlation, such as covariance, correlation coefficient, and statistical tests such as t-test. In Jupyter Notebook, we open statistics file, starting with the importing libraries, import math, import statistics, import NumPy as NP, import SciPy.status, and finally import Pandas as PD. Then we create some data, we name it X, and writing the type of X, list. Then X equal np.arrayX, change our data to NumPy array. Then find the minimum of X by using the function print x.mean, and for maximum print x.max, for mean print x.mean, for var print x.var, and for sum print x.sum. For finding median, print np.median x. The mean is 8, maximum 30, mean 16.8, var 48.36, sum 168, and median is 16. Measure of central tendency, print x.mean, and we can also calculate it by using mean equal sum of x divided by length of x. For harmonic mean, we use h-mean equal length of x divided by sum 1 divided by item for item in x, which is 14.22. Then weighted mean, y equal 1, 3, 5, 7, and so on. Finding weighted mean, then write our result, which is 18. For geometric mean, we use SciPy.stats.gmean of x 15.47. For median, we can use statistics.median of x. For mode, we can use statistics.mode of x 16. Then we have measures of variability, such as variance, by using statistics.variance of x 50, statistics.stdiff, standard deviation of x 7, skewness of x 0.58, fifth percentile, np.percentile x, 5, which is 8.45, and for 95 percentile, 27.29. In the same way, we can find 25, 50, and 70 percentile. Ranges, the difference between maximum and minimum, by using np.ptp of x. The result is 22. Or we can calculate by maximum of x minus minimum of x. For summary of descriptive statistics, we use scipy.stats.describe x base equal false. We have novice 10, minimum, maximum, mean, and so on. We can name our result st, for example, equal scipy.stat.describe of x, then write our result. We can use describe function from Pandas library by using x equal pd.series, some numbers, then x describe, the result is count, 5 numbers, mean, standard deviation, minimum, percentiles, and maximum. Measures of correlation. Correlation implies association, not causation. Correlation coefficient can measure the correlation between two variables. Let's create some data, x and y. Then find covariance between x and y. We name it cov matrix equal np.cov x and y. Then print our result. The covariance is 12.26. To find R between x and y, we can use STD of x standard deviation equal statistics.standard deviation of x STD of y statistics.standard deviation of y. Then find covariance of xy. To find R, we can use this equation. The result is 0.33. We can use Pearson correlation function. For example, R and P equal SciPy.stats.Pearson R between x and y. Then print in R and P. P-value is 0.34. To find linear regression, we use SciPy.stats.linear regression between x and y. Slope 0.24, intercept 5.1, R value 0.33 and P value 0.34. To find only R from the result, we use R equal LG dot R value, which is 0.33. Then for hypothesis testing, from SciPy import status, testing t-test, stats.t-test, one sample of x. The result is 7.4 and p-value is significant. For two sample of t-test, we use stats.t-test underscore ind between x and y. For multiple regression, from statsmodels.formula.api import OLS grand model.summary. That's the result of OLS regression. Analyze of variance ANOVA. X equal these numbers and y 1, 3, 5 and so on. B equal to 4, 6. Data frame equal pandas dot data frame x, y and b. Then finding a value and p value of x, y and b by using stats.f one way, x, y and b. Then print our result. A value is 4.57 and p value 0.01.